Okay, I'm live. Let's do this. So for starters, I want to implement just a normal binary search tree. So I have that as a start. So let me think about this. First thing I need is a node class. Define init self and we need a value where is add? Value, we need, I'm gonna do a child, let's see, left, use my, I'm not gonna worry about that. Left child, right child, parent. Self.value equal value, self.left, oops. Why is it not, whatever. Oh, I see why I didn't fill that in. Self.right child equal right child, did I spell that right? Sure. Self.parent equal parent. Let's see. Now, define, take it to string of self, obviously, and only self. That's all I need. Start with an empty string. S plus equal node with value. I'm gonna make this an F string. With value, let's see, what else do I want to say about it? With a left child having value left child, oh, this needs to be self.value. I need to remember that it's an attribute. Self.value, self.left child, a right child having value self. Oops, I don't want to put in left child. I just want to put in left child dot value. Self dot left child dot value and a parent having. Let's start a new line here. Is that? That's kind of weird. I'll see if that works. Actually, I might as well do this over there. Value self.parent dot doesn't know that that's what that is. Okay, now let's just test this basic stuff. Import binary search tree dot node. I want to do from. Import node. I think that's all I need. Yep, it's working. 27. Do it with no parents. Oh. That's gonna good reference error. Shoot. Also, I want this to be. I don't need a default value for value, but I do want it for right child equal none, parent equal none. So if I call self.leftChild, I'm going to get into trouble because it doesn't exist. I am going to put in a default value for that one. Okay. If self.leftChild none that's not a comment, that's a self.leftChild.value or equals no self.leftChild equals node of none. So the value is going to be none. I don't need that semicolon. If self.right, why doesn't it like this? Oh yeah. If left child is none, that'll work. So right child is none. Self dot right child equal node of none. If self dot not sure I need it to be this verbose actually, but I think I want it this way. Self dot parent equal is none. Parent equal node of none. Self.parent. Okay, now I can go back to main. I can just call this a node 27. This should get that done. Let's run it. Returned none type. I have to remember to return the string. That's pretty basic stuff. Run that. With the left child having value none. And it's a little bit misleading. It doesn't actually have a value none. It's actually that there isn't one. But I'll remember what that means. Because if the node actually exists, if the node actually existed, it would... Oh wait, this is a problem. Okay, I'm gonna simplify this. I can use debugging to check on the parents and stuff. I knew what, I don't need all this S and return and everything. I just need a return. Just a return statement. That'll be enough. Okay, let's run this again. Okay, node with value 27. Now let's give it parents and stuff, a node of 5 for its left child, a node of 6 for its right child, and a node of 82 for its parent. Why not? This is not necessarily fitting the binary search tree property right now, but that's not important. Oh, print my node dot right child, print my node dot left child, print my node dot parent. Okay, that all works. Those are linked up. So now I'm ready to make a tree class. Tree.py class tree, and I believe the only thing it needs, if I remember, the only thing it needs is a root. So def init self do I want it to have a... No, I don't want it to have anything to start with. Definite self dot root equal none. So it gets initialized as an empty tree. That's the way I want it. Def str. How the hell am I gonna make this into a string? First, a string of self. For now, I'll just make it a string with root whatever. Return format string self dot tree with root, and then format self dot root. I think that's all we need there. So let's test that out from binary search tree dot node port tree. Why does it look like that? Oops, binary search tree dot tree. I can take away all this. Oh, I should be committing this stuff. I haven't initialized a Git repo yet. Git commit message first commit and second message already created node class and tree class for binary search tree. Oh, I did, but I didn't add any files. That's nice. Let's see. vim.get the ignore. Add to this. Oops. Insert dot idea / all. Right quit. Get add get ignore. Add get ignore. Okay, and have I no get log. Oh, that's the okay. Now can I add all? And try that commit message from before. It's not actually the first commit, but whatever. Okay, working tree clean. We're good. Why is there nothing in here? Because I deleted stuff, that's why. Okay. My tree equals tree of a node with no. It's just a tree. Well, I'll need an add method, but print my tree. Tree with root none. Okay, good. And I think I can just manually tree dot root, oh, my tree root equal a node with value 28. What am I missing? Let's debug this. Oh, that's after that one. Well, no wonder. Okay, that's better. Okay, that's working. Now we need add. This is going to be where it starts to get interesting. Add node. Or do I want that capitalized? No, I don't. Self and a value for that node. So, do I want a value or do I want a node type? I'll make it. Yeah, I'll make it. I can always create a node when I call it. I'll do it this way for now. If tree, if self dot root equal none. Oops, need a comparison equal here. Why didn't I like this? Is none. Self dot root equal node. Not root. Root equal node. Okay, test this. My tree equal tree. My tree dot add node of a node with value 29. So run. We'll use the debugger to check on this. It's nice how it gives me the string representation right there. Okay, that's good. That's the first case of that. Now I'm going to refer to my note, well, my textbook, on how to do this insertion algorithm. I need to set the... Oops, I was thinking JavaScript. This is Python. And I'm glad it's Python, I really am. self.root.left child self.root children and parent are none by init. So that's fine. Do I need to import node into tree? I don't think so, because I don't think so. Else cur node equal tree self dot root. And self is a tree, yes. Cur node equals self dot root. Why isn't it like that? Oh, variable should be lowercase. Yep, that's true. While cur node is not none. Oops. While cur node is not none. Remove redundant parenthesis. Fair enough. If node key, or in my case value, if node.value, and node is the one we're adding, less than cur node dot value, cur dot left equals node left. Wait, no, that's not right. If current node dot left equal none. This is getting kind of messy. We'll do is none. If current node dot left is none. Come on. Node dot left equal node and current node equal none. You know, this is simpler. I can just say, well, current node. I don't need to say is not none. Else, and this will be the case that, in this case, node.value greater than or equal to cur node.value. If cur node, right, if not current node dot left. If not, and I'm going to change that here. If not current node dot left. If not current node dot left. current node dot right equal node. Why isn't it automatically? Oops. Current node dot left. Okay, something's weird here. If not cur node. When my IDE isn't making the colors I expect, it usually means if current node else if not current node dot right okay, then current node dot right child equal node. Else, wait, did I forget the else here? I sure did. Cur node equal cur node dot. I'm not sure why it's not smart enough to fill that in. Else cur node is right road, and then cur node equal none. Else node equals cur node dot, because then we keep looking on the right side of that. You know what? I'm gonna have to go through here and come back through here. Remember, add parent references. And then after the while, we set up the children of node are already none. So that's that. Okay, remember to add parent references. So where do I need parent? I need to give the I need to give node parents. Self.root parent is also already none, which is what it should be because the root has no parent. It only has children. Current node equals self.root while current node. If node.value less than current node, we're going to add over here. We're going to add current node.left and node.parent. Nodes only have one parent. Equal current node, right? That looks right. Now we have the same thing over here. Else we keep looking, so we don't need to assign a parent there. Okay, we should be ready to do this. Should be able to add a number of nodes. Tree.add node of a node with value 32. My tree.add with a node with value of 100. Why so many parentheses? Because I wrote a redundant parenthesis. Okay, debug on that line. It's got a root, it's got a left child, which is none. Makes sense because everything I got a right child, which is value 32. Meanwhile, root has, let's see, why does value get shown last? I said it first, maybe it's alphabetical. Elemental PQ, yeah, it's alphabetical, fair enough. although it's in the string representation right here, so that makes it easier. Anyway, right child has a parent. Oh, good, has... But the root doesn't have... The root does have a right child, left child, parent, right child. Okay. Its right child is a node. It has a left child that's none, a parent that is notify 29 up here. Good. And it has a right child, which is a notify 100. That right child has left child none, parent, notify 32. Okay, this is all working. That feels good. I'm not terribly interested in search, although for completeness I might include it. I gotta fill my water bottle, I'll be right back. You stream to Twitch and YouTube. Huh. Restream.io. I don't think I'm gonna run this today, but might run it the next time. See what the pricing is. One extra destination. 30 plus streaming platforms, one channel per platform. What does one extra destination mean? Oh, more than one channel of the same platform. Okay. Cool. I'm happy with the... I'm not going to do this right now, but I'm definitely going to check that out later. I was looking at a thing called Restream, which would allow me to... I stream from my computer to Restream servers, and then Restream serves that simultaneously to Twitch and YouTube. Pretty cool, I think. Okay, what's the next thing I'm going to do? Binary search tree insertions, I got that. BST search algorithm, and then BST search trees as just the concept of it. Well, there's search, but why does it have a whole nother search algorithm down here? I guess it's just another presentation of the same information. Okay. Hide that guy. Def search. And I have to think about whether I want it to return a reference or a... well, I don't want it to return the value, because I want it to return a reference, which then, depending on what I do with it, I can either interpret as... I can always interpret it as a Boolean, because I return none if it's not found. So, I should be adding some doc strings here. Def search of self value. Yeah. searches for a node with the given value. Return is node. Oh, maybe it should be inside of there? Okay. Let's look at their thing. Tree and key. Current node, oops, lowercase, equal self.root while current node is not null, so just while current node, if key equal current node dot key, so if value equal current node value, then we just return our node. We found it. Otherwise, else if value less than current, what the? Else if value less than current. Oh, else if is incorrect, should be elif. Elif value less than current node. Elif value less than current node. Start out equal current node dot left child. Do I have just left somewhere? Oh, Curnow dot left, sure enough. Gotta be careful of that. Do I have? Okay, I don't have left followed by a space anywhere now. Okay, else in this case value greater than or equal. Oh, this is some silly music. Node equal Curnow dot. Look at the right child. And if it hasn't found anything and current node is null, then we return null, none. Okay, let's test this search algorithm. Print search for value 100. Oops, no. Unresolved reference search. Define search. Oh, it needs to be. It's a method, so it needs to be called on my tree. Right. Let's debug this. Why is it? Oh, oops, if value less than current node dot value. Okay, let's stop and restart. Found node equal mytree.search 100. Let's debug that. Found node is a node with value 100. Okay, and if we do 200, and we run the debugger on that, then we get found node is none. Okay, cool. We got search in place. I already did insert. Given a key, a BSD remove operation removes the first found matching node. Okay, so when we write def remove node of self value docstring moves the first found node with the given value. Because there may be more than one node with a given value. Return, what is it? What does it return? Either a Boolean, let's see what they do here. I'm gonna have it return a Boolean. Returns true if node was found. If node was found and deleted. You know, I just realized if I'm streaming simultaneously to Twitch and YouTube, I'm breaking the terms of service on Twitch, so maybe I won't do that. Might be breaking the terms of service on YouTube too. Okay. It's got, oh, this one's written with parent. I guess because it needs that. So this is going to look a little different because of the fact that I have a parent reference in each node. So I don't think I have to define parent to start with. Self root while cur node if cur node dot value equal value, remove, what's wrong with this? Oops, double equal, I always forget that. Remove cur node. If cur node dot pair. What? Why doesn't it pick that up? Wonder if it would be smarter if I imported from node, import node. Oops. Ah, whatever, I don't need that. If Curnow.parent, if it has a parent, if not Curnow.parent, oh, first we check if it has. If not Curnow.left child and not Curnow.right child, in this case, current node is a leaf. stop the debugger. It doesn't need to be running in the background right now. Okay, if not current left node, where am I? This is to remove a leaf. We're in this bit of code now. If current node dot if left and not current node dot right. If not parent. If not current node dot parent. To set the tree root to null. None. Else if elif. I don't know why Python uses elif instead of else if, but whatever. Else if else if parent dot left equal current. Why does that self? No. It's self over equal none. If parent left equals current, parent is. Where did they set parent? Okay, it stores parent when we look at the next level. Okay, that makes sense. Parent, so parent is, so it's current. I'm going to find it as Curnow. Else if elif Curnow dot parent. Oh, current node dot parent dot left child equal so if current node is a left child of its parent. Okay, I see where this is going. Parent Curnow dot parent dot left child equal none. So current node dot parent doesn't have a left child anymore. Okay, fair enough. In this case, node dot parent dot left child equal it's right child. Else, that's the case that, so that's Curnow dot parent dot right child Chile? That's not right. Cool, none. Boy, this one's pretty involved. Okay, and that one. Now we're onto the net. Now we're onto the else if coming from the if not current left. Okay. If current node dot left child and not current node dot right child. What isn't it like? Illegal target for variable annotation. Huh? There's probably a typo in there. I'm just going to type it again. If current node dot left child, current node has a left child, and not current node dot right child, what? Anyone want to help me on the chat here? What am I missing? Oh, I'm on the wrong indent level. Illegal target for variable annotation. Wait. Illegal target for variable annotation. What's for variable annotation? PEP 526 syntax for variable annotations. So why is this one okay? Elif, does that break it? What? What's wrong with this one? Let's try something here. If false, pass, elif, what? End of statement expected. Oh, it's yeah, I see what it is. A dangling parenthesis that wasn't supposed to be there. That was my source of woe. Her node has left child child chilf. Okay. If Curnow, if not Curnow.parent if not Curnow.parent node is root, tree root equal current left. Oh, okay. That makes sense. Oops, left child. Let's make sure I have left child, left child, left child. Okay, that's fine. What's wrong here? Missing a space. Self.root equal Curnow.left child. Else if parent left child equal current. L if Curnow, oh come on, the parent Curnow.parent dot left child equal node Curnow.parent dot left child equals Curnow dot left child. So that makes sense. Else what is this one? Node dot parent dot left child equal Curnow. Is that right? Code, oops. Parent Curnow.parent dot right child equal Curnow.left child. Oh, I see what's happening here. Curnow.parent.left child equals current node. I'm not sure I quite understand what's happening there, but I'm gonna move on. L if, so this is going to look like that one. L if not Curnow.left child, node has right child only. If Curnow.parent, if not Curnow.parent, tree root equal current dot right. This is a tree method, right? Yeah. Okay, good. Current self dot root equal cur node dot right child. Okay, that's easy. L if current node dot parent current node dot parent. But wait, what? If not parent. Oh, else if parent. If parent left is current node, otherwise we're going to look at if parent right is current node. Oh, we're finding out whether current node is a left child or right child. Okay, got it. Else if current node dot parent equal wait, current node dot parent dot left child equals cur node, oops, equal current node. Current node dot parent dot left child is current node dot right child? Why is that? Current node dot parent dot left child. Okay, current node dot parent dot left child. Current node dot parent dot left child equals current node dot. Why right child? Why not left child? Not sure about that one. Else current node equal current node dot parent dot right child. Else current node dot parent, what the? Current node dot parent dot right child. Oh, right, we know that current node has a right child only, so yeah, that works. Oh, gosh darn it. Just poked myself in the eye a little bit there. 1 second, I'm gonna glance at something over here. Else has left and right children. Else let's use how do you spell successor? Oh, whatever. I'll do it suck like they do. Equals current node dot right child this is current node dot right child while successor, oh right, dot left, wait, what the hell? I I feel like it wants successor to something else. How do you spell successor? S-U-C-C-E-S-S-O-R. English is so ridiculous. Well, successor dot left child. Oh, we can remove the redundant parenthesis. Well, successor dot left child. Successor data equals create a copy of sucks data. That's weird. That's a weird way of writing it. Successor dot value. And now we recursively call remove node. That's interesting. Remove node of no, self dot remove node of self and value. Oh shoot. Oh, okay. Self.remove node successor.value. Assign current data with current node's data with successor data. Not sure why we have to do that after this, but I'm gonna trust it. Current node.value equals successor data. Now we return true, capital case, true. Node with value has been removed. That was kind of a bear. Ooh, a little lightheaded there. Elif, and now we're in. Let's close off all of that. If Curnow.value equal value. Okay, now we're going to deal with if less than or greater than. Elif Curnow.value less than P. What do we have here? I got a text message. We need more BORT license plates. In the gift shop, repeat, we need more BORT license plates. I'm having trouble spelling here. Let's Curnow value less than value. Parent is girl. I don't need to sign that because we've got parent references. Curnow equal Curnow dot right child, and else is going to equal Curnow dot left child. And if current node becomes none, then we'd return false. Well, current node to do the stuff that deletes it, and otherwise return false. Oh, if false pass. I don't know why I put that there. I don't remember why I put that there. I was trying to track down a problem. Okay, that should be it for that. Let's try it out. I'm gonna import. I'm gonna add some random numbers to the import. Random. Okay. What did I do? Import random. Let's. I could have done that differently. I forgot about that. Oh well. For I in range 15, we'll do 15 numbers. My tree dot add node of random dot, I think I want random dot rand int. Random.randint. Okay, and then I'll pass down here so I can check with the debugger that we've got a tree. What's wrong here? If node.value less than current node.value, function has no attribute value. How is node a value? Or is how is node a function? How is current node a function value? That's weird. Self.root. If self.root is none, self.root. Current node. Oh, I know what I did. I see what I did wrong. I had to call randint rather than feeding in as a function, so now it gets the result of that. Okay, that's gonna work better. Oh, I need to tell it the positional arguments. Alright, fine. 1 to 100. Still a problem. Int object has no attribute value. How did node end up being just an integer? Oh, no, we need to make it a node with that value, because that's the way I wrote it. Did that the way they wrote it? No, they wrote it with tree and key. Huh, maybe I should have done it that way. Alright, do we have a error this time? We do not. Left child with 52, left with 51, right with parent is 91. Right now. Okay, that's all looking good. Whew. EST in order traversal. I think this one's pretty easy. Yeah, I'm gonna go ahead and write this one. It's a good check that everything's working. I wrote remove node before add node. That's interesting. Maybe I didn't write it before. I don't know what order I added. Oh, I made. Okay, I should stop this and commit implement tree methods. Implement tree methods of what did I add? Added add node of self, search, and remove node. Add node, search, remove node. Okay. I'm gonna, well, whatever, it's fine. What's this do? No, I don't care about that. I'm going to just do this a little bit differently. Add node by value of self, comma value, and then I just need to create a node, return add node of value. Oh, self? Unresolved variable node. Maybe I do have to import from binary search tree dot node import node. Okay, that works. Add node by value of random.rand int 100. Try that again. Randing. Try that again with the right thing. Okay, that's good. Follow the left child with 9, left child with, oh, it doesn't have another left child. Okay. Follow the right children. 91, right child 96. Okay, this is all looking good. I'd like to have a better way to print it. Maybe I'm going to look into that. I'm going to steal some code here. We got it in Python 3. Root, comma, space. Okay. Def pretty print of self. That's just self. And now can I just copy this code in here? Function to print a 2D representation of the tree. Source. Return none. Let's see here. Why does it need to create a bunch of root equal new node? Where's the class new node? Def init self key. I already have that kind of code. Okay, I'm gonna okay. Self dot okay. Okay. Self dot root. If not self dot root. Print. I'm gonna go ahead and print empty tree, even though my source over there didn't do that. Space plus equal count 0. But what is count? Oh, count equal 10. I might need to be more clever with count, but count equal 10. Space. Where's space? Is it gonna print itself? Call itself at all? It is. Define. I'm pretty sure I can define methods within a local function. No, it's not used. That's fine. Print 2D util. I'll go ahead and call it what he does. I'm going to call this Curnow because I have a feeling it's going to work that way. Is it just not used? Print 2D util. Node equal, if not Curnow, oh, I don't want to say string because it's going to get there eventually. Space plus equal count. Do I not need to have count in there? Space plus equal count. Count 0. Print 2D util. Of Curnow.write child space. Print, so that gives us a new line for I in range of count 0. I don't know why count is a list because it doesn't seem to be adding anything to it. Print and equal looks like 2 spaces there. Curnow.value print 2D util of Curnow left child. What's wrong here? Print 2D util of root, comma 0. What's wrong with count? I don't know why count is a list like that. Now let's try it. mytree.prettyprint. Well, let's try it. Oh, stop and rerun, sure. Didn't think so. Count is not defined. Count is right here. Do I need to put count up here? Space plus equal count 0. But I declared global. What if I just say count equal wait. What? That's almost right. Or maybe it is. $34, $37. Something's not quite right. What if count equals 5? Looks pretty funky. What's it supposed to look like? Yeah, it doesn't look much like it's supposed to. There's some things about this I don't understand. Okay. Let's just run this how it is. Yeah, it works. But why is count the way it is? Looks like it was 15, 7, 15. I must be close because I'm managing to print something. We've already got self dot left, self dot right. Def print 2D of root is if root equal none. Return space plus equal. Print for high end range. Count print n equal space space. Oops. Space. That might be the whole problem. What? Oh no, that's the initial call. That should be 0. Oh, maybe it is working. 46 has 70 and 4. 70 has 90 and 47. 90 has 70. 47 has 53. 53 seems to have 54. 33 seems to have 6. 6 has 27. So, oh, it works. Cute. Now what does count equal 5 do? Oh, it's not being used. Count equal 6. No, let's try 2. That's just how much spread out it is. I think let's try it with 1. Oh, clever, it's in order in this way. 1 is too little. What if I do 0? That's just an order traversal. What if that was the depth of the tree? I don't think that makes sense. Oh, interesting. 98 is the root that time. 92 is the root. 69 is the root. 30 is the root. Pretty sweet if we could have, like, lines connecting them, but I think that's a little too much to ask. That would be really tricky. Alright, I'm gonna take a short break. Enjoy the music. You know what? I could, like, tweet out the fact that I'm streaming right now. I'm gonna do that. Some business intelligence solutions company followed me. That's kind of neat on Twitter. I don't know if it means anything, but oops, it's having some issue with my connection, isn't it? Okay, why is that having trouble? Is it still stuck? Looks like it's working again. Sorry if the stream kind of cut out there for a bit. Okay. So what did I add this time? Value and pretty print. Okay, now what? In order traversal. Okay, yeah. What's wrong with the name of this one? Oh. Oh, that's his code. I don't care about that. Def in order traversal. That's gonna need some arguments. It's kind of dark in here. I'm gonna turn on a light. Print self, just self. I could call that print in order traversal, and then I'm gonna define in order traversal util, and that's gonna be of current node. I think that's all. Do in order. So why isn't it not? Self.inOrder traversal? Yes. It does need to have self here. of, I think that's just, oh. Yeah, that's okay. If Curnow, if not Curnow, oops. If not current node, return. Otherwise, we're going to do in order traversal till, what the hell? Oh, it's not of self. I guess I do need to Curnow.left child print. I just want the value. Curnow.value. Curnow.in. I guess I guess it needs to know where to look for the thing. Traversal utility of Curnow.write child. I don't know why it doesn't help me autofill that. Curnow.value plus. This is going to have one issue with it, which is just that it's going to have a trailing comma where it doesn't need to be, but I'm not concerned about that right now. I'm going to do a double braces situation so I know so I can tell that it's a special thing. Oops. And equal none. Need a comma there. Print. Okay, that should work. Tree print in order traversal. Okay, this should just be a simple matter of running it. Oops. In order traversal utility takes one positional argument, but two were given. Huh. I guess I need to feed itself, otherwise it gets fucked up. Pardon my language. Node object has no attribute in order traversal. Node. Oh, self dot in order traversal. Okay. Make sure that it's actually making a tree. Oh, because I'm running tree, that's not what I want. Might have been better to use an F string there. Run main. Oops. I don't want that to be all a bunch of different lines. And equal not empty string. I'm going to throw a space in there. Oops, I expected spaces. Okay, we've got the in-order traversal. Height insertion order. That's interesting, but it doesn't have anything that I don't want to. Parent node pointers I've already. Oh, they had the insert replace child. Oh, that's BSD remove key and BSD remove node for BSDs containing parents. So it was all there for me already. That's funny. Okay, so I have add node by value, I have add node, I have search, I have remove node. I might like to have a remove node by node reference. I think I can package that. Let me commit what I've done recently. Whoa. How did I get to this view? Hopefully it'll, oh, there we go. In order, oops, print in order traversal. Okay, I want to refactor this now by taking out all of that. Okay, that's going to break that for the moment, but that's okay. This one should be defined above. No, that's not right. Oh, that's not at all how this is written. Okay, never mind. I have to like totally start over. Actually, just I'll get reset hard. That's better. Okay, what do I want to do now? I want to set this up as a red-black tree. Left rotation algorithm, is there going to be a right rotation algorithm? Yep. Okay. Now it's time to move on to a red-black tree. Not read. So I'll start by copying everything here. Oops, not test print. Yep, red black tree. Don't add them just yet because I'm going to change their names potentially. That was a silly little bit of jazz. I'm going to call this RBT node. I didn't refactor those things. It's kind of annoying. Wait a second. Yeah, red black tree, red black tree, red black tree, okay. RBT node, tree, where's refactor? Rename. Red black tree.py refactor. Oh, that's god damn it. Kind of get reset hard. I might be better off making a whole new project. I'm gonna do that. Delete this. An existing interpreter, the Anaconda, the Python 3.7 Anaconda. What the? Okay, that already exists. I'll just use camel case. Now, new window. Copy those. Paste. Import. Okay, that's gonna have to refactor a few things, but I don't think it'll be too much bother. Class. Actually, tree is the only one I really need to. From node, import node. From node, import node. From tree. tree, import tree. Maybe I won't bother renaming all these things. Oh, what the heck? Okay, time to start implementing some work. Okay. Now we're going to have to add a bunch of stuff to make this compliant with red-black tree. Oh, for one thing, node needs self.color. I'm going to equals color. Color equal none. Hold on, I'm gonna take a break and check on something. I think it's time for a change up of the music. Time for something new. Ooh, dreamy mood, that sounds good.
I know that
Okay, there we go. I like that. Okay, so we added color to that. Okay. Tree set child, I'm not sure why we need that, but that's the next one in my book, so that's what we're gonna do. Set child of self. I don't need the parent because I have the reference for that. Which child, oops, which child, snake case. I think it's called snake case. Which child, child. I'm going to call that child node. Okay. If which child not is this the symbol for not equal in Python? Maybe static? What does that mean? Well, let's not worry about that for now. Oops, and not equal right. That seems like an unnecessary thing since I should be able to control what I get in there. If which child equal left child node dot parent dot left child node dot parent dot left child child node dot parent dot left child equal child node else child node dot parent dot right child. If child parent equal parent, if child not equal no, why is this necessary? If child node child node dot parent equal parent, but parent isn't defined. Maybe I do need to have parent in here. Okay. Now I'm going to call this set child util. What happens if I make a function from method? What the heck is a static method? Learn something every day. I mean, I'm assuming I'm going to learn this. Oh, I just need to include self in the okay. Def replace child util self current child new child. Oops. If okay, if parent left child parent.left child equal current child, return set child util self dot set child util. These maybe should have been static methods, but I'm gonna let them be the way they are. Self dot set child util of parent left new child. If return set elif parent dot right child current child, not right child, we need right child. Return set child util. Why is it not prompting me with that? Util of parent right new child, like that. Oh, it needs to be self. There we go. Let's see, how would I test this? By value of 27. Let's search 27. I'm not exactly sure where I'm going with this, so I'm not going to give it a meaningful name. A node. Maybe that's supposed to be a node method. Huh. Parent, current child, new child. I'm gonna call this new child node equal node of 38, 38. Not that it matters. Old child node equal mytree.search27. mytree.replace child of old child node.parent old child node new child node mytree.prettyprint. We got some issues here. Where's debug? Node with value 38. Uh-oh. Oh, it doesn't have a... Oh, okay. I think an error print might be more useful. So there's 38. Oh, but it's in the wrong order. Well, maybe... It's probably not the case that I would actually use it in that way. But it is successfully replacing a node with another node. Okay, let's commit. Oh, I don't have a Git repository yet. A lot. Oh, it's not time to commit. I need to... Git add main .py node.py tree.py. I'll just call it first commit. That's good enough. Why is it not showing it as in there? Oh, just was a little slow. vim.get ignore insert dot idea/all. Write and quit. Okay. What is high cache doing here? Oh, it's hidden. Huh. I think that was called PyCache. Yeah. Add git ignore. One second, I'm gonna go check on something. You know what? I'm getting distracted, and I think I'm ready to call it on this stream for now. So I'm going to do that. Thanks for watching, and bye-bye.